you very much. I got the same problem as Nicole, being too short. But I've got a short time only, so I would like to introduce you to a project. Some researchers from Flinders University and Adelaide Uni did, funded by some local government agencies and state government agencies. And I want to focus on some of the urban environment, a bit of green spaces and the street canyons. It's not only a climate change issue we probably have to talk about, it's something with population growth as well. And the building height changes in the Adelaide CBD, for example, that will have consequences on our climate in the city directly. So if we talk about hotspots in the CBD, which we measured with temperature sensors, but the thing I show here is more from a pure radiation budget perspective. So what we did was we used the three-dimensional model we do have from the Adelaide City and calculated the incoming radiation, the outgoing radiation from the buildings as well, although we didn't use direct measurements from building heat exchanges. We just used the pure radiation from long wave radiation, solar radiation exchanges. What we do see is that this is called the sky view factor, that this is depending on the building surroundings. And there are two pictures here which I can show, which show you the Curry Street environment, the Flinders Street environment. So lots of big buildings, heat is actually trapped in these areas. And we then see that especially the building where the hottest places are, this is where the biggest buildings are. Going further, increasing the height now of some of these buildings, and this is just one sample we did. I'm not 100% sure if we actually use the newest changes which are proposed for the building height changes in the city. So if you have this change in building heights, you can do the same calculations and find out what that means for your temperature changes. If we do this, we do see a change in an urban heat island impact, so in hotter places in the city, and especially these red places here. This is the left-hand side is a summer case, this is a winter case. So the left side here we see up to 1 degree differences, so warmer air in these canyons, while in winter it even goes up to 1.5 degrees. This urban heat island is much more dominant in winter, as we can see from measurements as well as from some of the calculations we did with the modeling as well. Going further, this is a summary of our measurements where we do distinguish between the different seasons, and you can especially see this blue one, winter. We have a very hot urban heat island or change between the CBD and green areas. And this goes up to an average of 1.8 degrees, but it actually goes up to 6 degree difference in winter between our parklands, where we are here, and in the inner areas of the CBD. So if you are feeling too hot in winter, you better sort of get your tent and get into the parklands. And this is also obviously some measurements we did between the parklands, where the nighttime temperature nicely goes down, it's very low in the early morning, and the city stays almost the same. We did some investigations of the different canyons, where you can see a temperature change with the width of the canyon. So the wider the canyon is, the lower the temperature will be. The height changes, the higher the building is, the above the ground, the higher the temperature will be in these canyons. And one other project we did there was looking at the different buildings. We took 3 buildings from the city, we got electricity numbers from these buildings, and we checked out what these numbers were in relation to temperatures. And you can see if the temperature goes up, the electricity use in these buildings goes up. You can see that there is a variation between the buildings, and this definitely depends on the building structures or the standards in the buildings. I don't tell you which buildings these are, but you can clearly see that in some areas the building, the temperature, the electricity use, goes up faster than in other buildings. And there's a minimum where we feel probably comfortable. And if we talk about carbon dioxide changes there as well, there's an increase in annual electricity consumption, and hence the CO2 production, which we can see for an increase in calculated increase of approximately 1 degree, which does change the whole environment. So first of all, electricity use goes up, carbon dioxide emissions go up. So we do have to act on that, and especially if we want to change the building height in our city, which means that we probably just due to radiation budgets, we get already a warming in the city area. And this should be it. This is actually the summary. Thank you.